All right, we're going to take a look at real life functions and how that operates and about how we model real life situations. Well, first of all, we have to realize that when we're talking about things in real life, our lives are not just a straight line going along as much as we like to think they are, but they're not. Sometimes good things happen, sometimes bad things happen. Our graph may go up, it may stabilize, it may go down, it may go back up. So basically, it's made up of a lot of different functions all put together. But one of the things we have to realize about our real life situation is that it all occurs in the first quadrant, because that's where the real world exists. Now, why is that? Well, in the first quadrant, everything is positive. We have positive time, we have positive other situations. So, for example, if we were looking at distance, we measure distance positively, don't we? We measure height positively. Temperature, we do have a negative below zero, but in general, when we look in the real world, we measure positively. Distance from home is measured positively, not -5 blocks from school. And along that kind of line. So let's take a look at how we're going to look at these graphs individually. And here I have 3 lines, a blue line, a red line, and a green line. And what we're going to do is take a look at these and realize the steepness of things. So as a line gets steeper, we can say things happen a lot quicker. As a line is lower, or closer to what we call a flat line, we're going to say that things take slower for them to occur. And this is kind of going to be the average. So if we can kind of take the angle as being when things occur, a little bit slower to occur because it's closer to the baseline, a little bit on the average, and a lot quicker. So we can kind of establish that. So let's take a look at just this going up, and here I have them numbered 1, 2, and 3. And we're going to use some words that we know in relation maybe to temperature, to height, to distance, that we could describe these lines that are going upwards. We might use words like rising or increasing, going up, or climbing. And when we, again, in reference to steeper lines, number 3, the blue line, is climbing a lot faster or a lot quicker. Line number 1, the green line, is increasing at a very slow rate, where line number 2, the red line, is an average rate. Still increasing, but at an average rate. Let's take a look at going in the other direction. And again, our dotted line represents the norm. So here we have 3 lines going down. And when we talk about going down, things that we could say, decreasing, dropping, sinking, these are some ways to talk about the line going downwards. And again, line 1 would be decreasing slowly. Line 2 would be the average. Line 3, the red line, would be talking about when maybe something is sinking fast, the quickness of things. So we talked about going up and going down. Let's talk about when something is just straight across. And if we're talking about it, and if we use our little thing here in terms of temperature, height, and distance, when something is straight, we're basically saying that it's steady, that it's the same, that it's not moving, it's consistent, it's pausing, it's stable. We're not seeing anything happen to the line. It is holding steady. So that's kind of what we're looking at in terms of temperature, height, and distance over a period of time. Now realize, as I've been showing you these graphs, all of these graphs have shown that time has been on the bottom every single time. And that's what we're going to be concentrating on, are when time is at the bottom of our graph and our y-axis or our vertical axis will have things changing on us, whether it's temperature, height, or distance. So we're going to take a look at a graph in general here. And here we have some time, over a period of time, and it's 1 through 9, and then here's the distance away. So I'm going to tell a story about the red line and the green line so we can kind of see what happens. So we're going to pretend this is my classroom right here, this spot at the beginning here at 0, 0. And we're going to talk about me walking up to the office from my classroom. Well, I'd say I leave my classroom and I start walking towards the office. And as I'm walking along, I'm just walking at an average rate. Well, then all of a sudden I run into a student. And I stand and I start talking to a student. As you see, it's stationary. And then as I'm done talking to the student, I realize I left something back in my room and decide I don't need to go to the office anyway, so I'm going to walk right back. And I'm returning back to where I started, at the bottom, which is the distance from my classroom. Now let's take a look at this green line. Let's say if I was leaving my classroom and I needed to go to the office and I realized that I have an appointment and I'm late, I might be walking at a faster pace than I was earlier. And that's what shows me is the distance away from my classroom. That's going at a quicker pace. So let's kind of put it all together a little bit. Let's kind of do it the other way, and let's see if you can write one. Let's say this graph right here represents your distance from home to school. And again, time on the bottom, and I have about 5 minutes there. Let's say you live fairly close to school. And if we're going to write a story, we're going to have to put it in sections. So let's section this graph off. And as we section this graph off, we're going to put them by angle. So we have the first section, which goes up and then stops. Then we have a flat section. We have a down section, and then we have a section that goes back up. Now we're going to label these as A, B, C, and D so that we can tell a story about what is actually going on over the period of time. So here I'm going to tell a little story. So I'm going to say, starting from home, I started walking to school. So as I'm starting to walk to school, then I get to where the next section begins. I'm going to stop and wait for traffic to cross the street. They could be waiting at a stop sign, a stoplight, but they're waiting for a minute, so more than likely a light, a signal. And they're going to all of a sudden realize they're going to think I dropped my lunch money and walk back towards the house. So they're walking right back towards the home because this is the distance from home to school. They're walking back towards home, still at the same pace, nothing really drastic. And then they're going to found it and realize that they were going to be late to school, so they ran the rest of the way to school. So they were going at a more increasing rate. It was rising a lot quicker. So in this way, we can show a real life function as a bunch of graphs put together so that we can describe a story and see what's happening. Another word for these types of functions are called piecewise functions, that they're made up of different things all occurring at the same time.